This is called tangents to circles. We're going to start out, you can use a straight edge for this. I'm going to use a straight edge, but you don't have to. You can just sketch it. We're going to start out by drawing a circle. It's a decent circle. What? Yeah, we're going to alternate between the homework and the notes. So, the first thing that I want to do is draw a tangent line to this circle. Just like sketch a tangent line. And then I'm going to connect this tangent line with the radius, with the center of the circle. That is always going to make a 90-degree angle. That's the first bit of information that we are going to be looking at. So, what I'm going to say is a tangent to a circle always contacts the circle's radius. Always contacts the circle's radius at 90 degrees at a right angle. Now, I'm not saying that any radius that you draw is going to make a 90-degree angle. If I drew a radius out this way, it wouldn't even be touching the tangent line. So the radius that you're drawing is the one that also touches the tangent line. And if it does touch the tangent line, then it makes a 90-degree angle. The other piece of information that I want to add to this is if you connect the center and this external point, you get a right triangle. Because it's a right angle, yeah. So, what's something that we can use on a right triangle? There's actually two types of things that we've learned so far that we can use on a right triangle. To find sides or angles. What, Byron?
Is it like the side equal side thing?
No, that's proving two triangles are congruent.
Oh, sorry.
SOHCAHTOA, if we wanted to find angles or sides, we could use SOHCAHTOA. What's the other thing that we could use to find sides?
A squared plus b squared equals c squared.
Yeah, the Pythagorean theorem. So, if you have a tangent to a circle and you draw the radius and connect the center and this external point, you can use all those things. That's the first thing that I want to say. Does anyone need this still? So, number 3. So on number 3, this will be for a piece of candy. Yes. Name the angle that's a 90-degree angle. Raise your hand if you think you have it. Aaron? Okay, yeah, it's angle C.
Is that a different way to say that?
Yes.
OCA.
OCA. Anyone else a different way to name it? Camilla? ACO, sure. I'll pass out the candy in a minute. Hold on. The next question is, what's the length of the hypotenuse? Raise your hand if you think you know it.
Please, I saw you look at me.
I know, but you got a piece of candy already.
But I just don't want to answer it.
Byron.
I think it might be 8, but at the same time, I think it might be longer.
Say it.
It's 8.
No.
I know what it is.
Camilla.
It's 12.
No.
Why is it not?
Tuesday.
Oh, 13.
It's 13.
Oh, listen.
Wait. Tuesday, how do you know?
Because the one
I
side
see
is
now.
5, and so if it's in like a circle, then they gotta be the same.
Yeah, these are radii of the same circle.
But I forgot what 8 plus 5 equals. Oh my gosh.
And now it's on the video.
I never remember.
No, it's not plus. Oh.
15. It's supposed to be 13.
No one can get it right.
Yeah, I know. I'm sorry. It's 13.
You're just gonna have to erase it. I can never have. I don't know. You can still erase it.
So that means we have a right triangle with a leg that's 5, a hypotenuse that's 13, and it's asking for AC. What is the length of AC? Which is the bottom. No, he's right. You can use a squared plus b squared equals c squared. You have c and you have maybe a. Oh, go ahead. Explain.
You can do 13 squared minus 5 squared.
And then what?
And then you have to what's it called? Square root.
Square root. Yeah, that's the way to do it without having to write down anything. This squared minus 25 squared, and then square root your answer. I'll write it all out in a minute. All right, so on this, I would say that bottom is a, so I could do a squared plus 5 squared equals 13 squared. So a squared plus 25. So I'm saying that this bottom side is a, this is b, this is c, and I'm doing a squared plus b squared equals c squared. Does that make sense to you?
Yeah.
Finish. So we could subtract 25 from both sides, and a squared equals 144. Square root a equals 12. And then that's actually our answer. AC is that bottom length, so we can say AC is 12 units long. Circumscribed angles. That's what we're going to be looking at next. What was so fun? I know.
Why do they have to call it that? No, what is funny?
They're saying it's like circumcised angles.
What's that?
Don't worry about it.
I'm kidding. I have to write that down.
Ice cream cone?
They look like an ice cream cone. Circumscribed angles. This is what they are.
We're still
Keep going. That's fine. That's fine.
Be professional here.
So I'm going to draw a circle and then an external point, and I'm going to connect that with tangents. So, oh, I missed.
Oh, that sucks.
In the video. In the video. No one's going to watch this.
Wait, does it pick up audio?
Yes.
Oh!
See? No one watches them. This is the circumscribed angle.
I feel bad. Circumscribed.
Oh, it looks like an
Yep. Very good.
I get it now.
Does y'all's voices like ever sound different on videos?
Yeah, 10 pounds.
Oh, that's...
No, it's not recording. We're just taking pictures.
Okay, well, if it's recording, then why is everyone talking?
Because they don't care.
No one watches.
I need my 5 seconds.
Circumscribed angles.
Let me ask you, do you ever
Wait. Shh.
No.
This angle is the circumscribed angle, and the piece of information that I want you to know before we move on is that the sides of a circumscribed angle, these sides, no,
I don't think I should say it.
I don't know. The sides of a circumscribed angle
I put CA.
are congruent. So that means this is congruent to this.
They're the same.
For number 2, This is what we have. That's the bottom part of an ice cream cone. Do we see that? There are 3 vertices. That means there are 3 ice cream cones. There's another piece. And then the last one. Or a really giant scoop of ice cream. Depends on how you look at it. Glass half full. So, with this, if I'm looking at each piece, what information can I add to this part of the picture? Raise your hand if you think you have it. So because this is a circumscribed angle, this and this are congruent, so we have 10 here. It's asking for the perimeter of the whole entire triangle, but we'll get there eventually. It's not just adding.
Oh, I have a question.
What's your question?
Does that mean that the other side's 14?
It does. How did you get that?
Subtraction.
Yeah, the whole thing is 24, and so you take away the 10, and you get 14. Okay, what then do you know about this? Grace? The other side's 14. We're just moving all the way around. I'm going to pause it and let you guys try and figure out the rest. So the rest of this part is also 5 because of this. They have to be on the same ice cream cone to be able to be congruent.
The thing that made me think that was 5 was because they line up with the other circles, be the dots, and they look
Okay. And then you add 5 plus 10 is 15, plus 10 is 25, plus 14 is 39, plus another 14 is 53, plus 5 is 58. All right, this second piece of information that I want to point out is actually, bless you. First, I'm going to draw this angle. Raise your hand if you remember what that angle is called.
Oh.
Obtuse?
It is obtuse, but that's not what I'm looking for.
Ha!
This is called the central angle.
Eve.
But what does that even mean?
Well, it's in the angle and it's in the center.
Not about that.
Oh, no. Can't help it.
And then the second thing, the second piece of information that I want you to write down is the central angle and the circumscribed angle are supplementary. Shoot. Is Byron talking outside? Huh? That means this angle and this angle add up to 180. There is a reason, you don't have to like memorize this or anything, but if you have, do you guys remember how many degrees are in a quadrilateral? How many degrees? No?
Yes. At least
360. That was what we were thinking of parallelograms. There are 360 degrees in a quadrilateral. The reason for that is if you cut any quadrilateral into 2, it makes 2 triangles. Each are 180 degrees. 180 plus 180 is 360.
Oh.
First, so in any quadrilateral, there are 360 degrees, which means we already found out that if we connect these angles, these are right angles, right? This creates a quadrilateral that has 4 sides. So if this is 90 and this is 90, that means 180 out of the 360 are already taken up. So this angle plus this angle have to be 180. Does that make sense? We don't need to know that part, but we do need to know that these angles add up to 180. All right, on this one, yes. On this one, this is the central angle. So both of these have to add up to 180. And we're trying to find the measure of angle O. So let me just do 180 minus 46, and you get 134. So that's the answer. Whoops, 134. This one is like 5, 10, and 11.
Wait, why would you? Oh, that's.
But these are both, they're supplementary. I want to explain something real quick for number 5. On number 5, if I cover up this situation was like what we had when we took the test. This is an inscribed angle. This is a central angle. How do you get from the inscribed angle to the central angle? So to get this, you would multiply this one by 2. If you had this angle, you could divide by 2 and get the other one. So this would be, what is it, 96? And then these angles have to be supplementary, so that's how you can figure out A. And that's it. Finally, we're done.
Okay,